Illustrating a random variable, distinguishing between a discrete and continuous random variable, finding possible values of a random variable. Gamblers' dispute in 1654 led to the creation of a mathematical theory of probability by two famous French mathematicians, Blaise Pascal and Pierre de Fermat. Probability has its origin in the study of gambling and insurance in the 17th century, and it is now an indispensable tool of both social and natural sciences. Statistics may be said to have its origin in the census counts taken thousands of years ago, as a distinct scientific discipline. However, it was developed in the early 19th century as the study of populations, economies, and moral actions, and later in that century as the mathematical tool for analyzing such numbers. Probability has two distributions: discrete probability distribution and continuous probability distribution. Under those two are discrete variable and continuous variable. Random variable is a variable whose value is a numerical quantity outcome of a random experiment. The reason why we need to learn and have knowledge about probability is because we use probability in a number of industries, including healthcare, scientific research, and weather forecasting.
Illustrating random variable, discrete and continuous. This topic was written collaboratively to help you in illustrating a random variable, discrete and continuous, which are essential in solving real-life problems. The scope of this topic permits it to be used in many different learning situations. This lesson is arranged to follow the standard sequence of the course. We are expected to 1. Define random variable, and 2. Illustrate random variables, discrete and continuous. Distinguishing between a discrete and a continuous random variable. This topic was elaborated and written to help you distinguish between a discrete and a continuous random variable. The scope of this topic permits it to be used in many different learning situations. After going to this topic, we are expected to 1. Distinguish random variables as discrete or continuous. Finding possible values of a random variable. This topic is here to help us master the process of finding the possible values of a random variables. The scope of this topic permits it to be used in many different learning situations. After going to this topic, we are expected to 1. Find the possible values of random variables.
Random variable is defined as the capacity that connects a real number with every component in the sample space. It is a variable whose qualities are controlled by chance. For instance, it is a variable whose values depend on outcomes of a random phenomenon. Discrete random variables are variables can take an infinite number of distinct values. In other words, it can be counted. For example, getting the result of rolling 2 dice only as the values of 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Continuous random variables are random variables that take an interminably uncountable number of potential values, regularly measurable amounts. To make it understandable, a continuous random variable can be measured. For example, a person's height or weight, time in a race, and a lot more. Illustrating a random variable, discrete and continuous. For a fair coin tosses twice, the probability of each of the possible values or number of heads can be tabulated as shown in Table 1. Probability of the random variable is equals to 1 over 4. Probability of a random variable equals 1 is equals to 2 over 4. Probability of random variable equals 0 is equals to 1 over 4. This is an example of discrete variable. Thus, a discrete random variable x has possible values of x1, x2, and x3. The table 2 shown an example of continuous random variable that is and only pertaining for a possible events that may occur with the said topic. According to Henry County Schools 2021, continuous random variable x takes all values in a given interval of numbers. The probability distribution of a continuous random variable is shown by a density curve. The probability that x is between an interval of numbers is the area under the density curve between the interval endpoints. And the probability that a continuous random variable x is exactly equal to a number is 0. Distinguishing between a discrete and non-continuous random variable.
Types of random variables. A discrete random variables, those values represented by count data. This happens when the set of possible outcomes from an experiment can be counted, such as the number of households in a barangay, thus making the values of the random variable countable just like whole numbers 0, 1, 2, 3. A continuous random variable is a random variable that takes values on a continuous scale. This happens when the set of possible outcomes from an experiment cannot be counted but can be measured, such as height of grade 11 students. Continuous random variables represent measured data like height, weight, and temperature. Finding possible values of a random variable. Finding the possible values of a random variable can take some possible steps that could lead to a findings for the result. Example, suppose 3 coins are being tossed. Let Z be the random variable representing the number of hits that occur. Now, we have to find the values of the random variable Z. As we can observe in the given example, the possible values of the random variable Z are 3, 2, 2, 1, 2, 1, 1, and 0.
Reflection. The researcher conclude that this topic of illustrating a random variable plays an insignificant part in statistics because in probability and statistics, a random variable, random quantity, or stochastic variable is a variable whose potential values are the result of a random phenomena, and it also helps students correlate all real numbers with each component in the sample space. A discrete variable is a variable whose value is obtained by counting, while the continuous variable is a variable whose value is obtained by measuring. In realization, this topic and also the statistic and probability is so helpful, and it can also be used in real life because it teaches students to the basic principles and logic of statistical reasoning and offers them introductory level practical capacity to pick, produce, and interpret appropriate descriptive and inferential procedure. This topic, as well as statistic and probability, is extremely useful and may be used in real life.